everyone, so in this video we're going to talk about data graphs and focus primarily on box and whisker plots. But just a quick refresher on some that you've probably seen before. So a line graph talks about continuous data. So it's usually linking up something over time, and then you draw a line just kind of connecting different values, like this wildlife population here, tracking how many bears we have and how many dolphins we have and how many whales we have. So you can kind of track the progress over time. A pie chart is helpful when you want to calculate the percentages out of a whole. So in this example, we've asked people what their favorite fruit is, and then like 27% of them said grapes. I don't know exactly how many people we asked, but 27% of them said grapes. So that is a pie chart. One real world example of a pie chart is budgeting. So like out of all the money that you make, you should spend certain percentages of it on different things. And people don't always agree exactly on this, but you should spend about 28% of your income on housing, like 15% goes to taxes-ish, 10%, maybe even 15% to retirement. So all of these different things. So for example, if I make $2,400 a month, and then I do 28% of that, I get $672. So basically that is what I should be spending for housing, so like for my rent or mortgage. A dot plot, you've seen these before. Dot plots are basically like bar graphs. You just put dots on whatever you want to add up. So like in this particular case, I've got 1, 2, 3, 4, 5 5s and 2 4s, and I've got 5 3s. So basically it's just like a visual way of listing out your data. And like I said, it's pretty much like a bar chart. So a bar chart, you just have different categories and then you count up the frequency. So like I have a little over 4 in category 1, and I have about 2.5 in category 2, and so on. Let's see. Bar graphs don't have to be numbers. Like these can just be categories, and they don't even really have to be that related to each other. Like they're independent of each other. This could be like different ice cream flavors or something like that. It doesn't have to be numerical data. All right, bar graphs and histograms look very similar, but they're actually different. Histograms, basically what you do is you come up with these bars, but each bar represents an interval. And we'll talk more about histograms in the next video. But basically, like if you have from 0 to 10, there are 2 people from 0 to 10. And from 11 to 20, there were 5 people. So I don't know exactly what those people are, but I know there were 5 people in that category. So basically you break it down into intervals, and then you dump your data into those intervals, kind of like buckets almost, and just count up, again, the frequencies. It's called a histogram because it's like the history, it's like historical, like it increases each interval. All right, and then lastly we're going to talk about box and whisker plots. It's called that because you've got a box and maybe some whiskers. Sometimes people just put the box. So sometimes it's just called a box plot. So what this really does is a box and whisker plot, you graph on a number line. And the reason we put a box here is because it's basically boxing the middle 50% of your data. Like basically what you're saying is like the data goes down to about 60 something and it goes up to almost 100, but the middle 50% of these test scores fell within 78 approximately and 93 or 94 approximately. This is the middle 50% of your data. You could even compare lots of box and whisker plots, and they don't have to be horizontal. You can make them vertical if you wanted to. So this is like a box and whisker plot for Monday, and there's one for Tuesday, there's one for Wednesday. And each of these you can look at the middle 50% of the data, and you can look at the whole range of the data. So let me refresh you on how these work. Just a reminder, sometimes they're just called a box plot, and you may not even draw the whiskers. So you start with a number line. If you don't have a number line, the box plot is kind of meaningless. It's got to match up with some numbers. So start with a number line, label some numbers, and then I want to remind you what this is. So the box goes from Q1 to Q3. It's basically the interquartile range. It's the middle 50% of your data. The line through the middle is the median, or Q2. And then you draw your whiskers out to the min and out to the max. Sometimes if there's an outlier, people will draw a separate dot for the outlier and then only draw the whisker out to like the next lowest point or the next highest point. So you'll see both of those actually, and you're free to do whichever you want. You can make the outliers separate dots, or you can draw your whisker all the way out to the outlier if you want to. Okay, so basically what a box and whisker plot is it's a visual representation of the 5-number summary. Your min, Q1, the median, Q3, and your max. Remember, you can use your TI-84 to calculate all this stuff, so you don't even have to calculate it by hand if you don't want to. So, and again, it splits the data into quartiles. This is Q1, Q2, Q3. So basically this right here represents the lowest quarter of data, and this is the next quarter of data, and then this is the next quarter of data, and then this is a quarter of your data. So like I was saying, this is the middle 50% of the data, whereas from here to here is the entire range of the data. So here's kind of some steps to take if you want to make one yourself. First, you're going to need to find the 5-number summary of your data and also make a number line. You've got to start with that. And then draw your box from Q1 to Q3, put a line through wherever the median is, and then draw your whiskers out to the minimum point and to the maximum point. And like I said, if you want to put a separate dot for outliers, you can. Do you like that box and whisker plot? Okay, so here's an example. I went ahead and just listed out the 5-number summary here, the min, Q1, median, Q3, max. Again, here's what I don't want to do. I don't want to just draw a box and some whiskers and just make it whatever size I want and be like, oh, that's 18, this is 31, this is 40, this is 43, and this is 45. Because that is really meaningless. I might as well have just given you this list. The point of the visual is to be like, oh, is it a really big box? Is it a really small box? Is it kind of skewed to one side or the other? So don't do that. Start off with a number line. I need my number line to go from somewhere around 18 to somewhere around 45. Maybe I'll just start at 0 and go up tens. 10, 20, 30, 40, 50. You can make your number line whatever you want to, as long as it includes all the data. And so now I'm going to actually put all of this on the number line. So 18 is right about here, and Q1 is 31, which is right about here, and the median is at 40, Q3 is at 43, and so that's my box from Q1 to Q3. And then the max is 45, which is not that far. So draw your whiskers out to the max and to the min, and there we go. You can label it if you want to put the numbers on here, but you don't have to because the number line says, like, that's 18, this is 31, that's 40. So you can just kind of tell from the number line. And there's my box and whisker plot. These can be very helpful to compare different data sets. So here's a little data, and it's a little old, but this represents the Oscar-winning actors and their ages, basically, from 75 to 04. So take a second and pause and just think, what do you notice about this data? All right, so one thing is you may notice this data actually did put separate dots. They actually put stars for their outliers. So basically that at some point there was a female who won an Oscar who was 60-something, and there was a female who was 70-something, and a female who was 80. Who was that, like Betty White or somebody? I don't know. And there was one male who was kind of old, 70-something. You'll notice in general that the males are a little older when they win Oscars than the females, because theirs is a little lower. Like females range from 21-ish to about 48, 49, whereas the males range from about 29 to like 60 something. That's not including the outliers though. If we're including the outliers, the females actually have a greater range. Looking at the middle 50% of the data, the males have a bigger spread if we look at just the interquartile range compared to the females' interquartile range. Notice if we look at the median, so this middle value here, the median female, so the very middle of the females who won Oscars, was about 34 maybe, whereas the median male is about 42 or 43, so slightly older. So yeah, that's how you can use these to compare two data sets. Here's one more example. This is looking at two different test scores. First of all, what do you think was the highest score on these tests? Notice that the maximum that anybody got was 21. So maybe 21 was the maximum score. The number line goes up to 24, so maybe 24 was the maximum score. It could be 100, we don't know. I hope it's not 100, those would be very low scores. But we don't know from this data what the max score on the test was. We just know that the highest anyone got was a 21 on both tests. Which test do you think had higher scores overall? And why do you think that? So you'll notice these are very similar data sets. They have the same min and max, they have the same median, and they even have the same Q3. So every quartile is the same except for down here. So test 2 had the higher scores overall. And you can tell this because its Q1 isn't quite as low as this Q1. So like the middle 50% of data here is a little higher than this middle 50% of data because it's all kind of scrunched together on the higher end, whereas this one goes a little lower. So like the 50% of people who scored like in the middle were slightly higher on test 2. All right.